Hello and welcome to this video on how to convert a delta network into a star network. So I will be showing you a trick or a shortcut approach to converting a delta network into a star network using this question displaying on your screen. Alright, so the question is simply saying convert the delta network into an equivalent star network. Okay, so this is our network. We want to convert this into an equivalent star network. So we have our star network, something like this. Okay, you have your star network, and of course this is our star network. So we want to convert this into an equivalent star network. Now the first thing I will ask you to do when given the delta network is find the summation of the entire resistance or the impedance on the delta circuit. So summation of resistance, summation R is equal to, add all of them up. So we have 420 plus we have 360 plus we have 220. So that's your first approach in converting from delta to star. First of all, find the sum of the entire resistor or the impedance on the circuit. Okay, so the summation of resistance is equal to, let's add this all up and obtain an equivalent value. So 420 plus 360 plus 220, that simply gives us 1000 ohms. So the equivalent summation of those resistance gives us 1000 ohms. Alright, so that's your first task. Your second task now, bring back the delta network. Okay, so you have your delta network. Okay, so bring back your delta network. Remember, we have here to be 420 ohms. We have here to be 220 ohms. We have here to be 360 ohms. Now, we want to convert this to equivalent star network. So this is our star network. So let's label here as R1 unknown, label here or call this RA unknown, call this RB unknown, call this RC. We need to find the equivalent of these values. Okay, we need to find RA, RB and RC, then transform this whole network into a star. So what you will do next is draw this star network inside the delta network. So you have something like this. Okay, you have this, and then you have this. All right, so from here you called here RA, so this represents RA over here. Then you call here RB, so this represents RB over here. Then you call here RC, this represents RC over here. Okay, now to find RA, you find the resistors from the delta network where RA is in between, multiply them together and divide by the summation or the total value of the resistor. Okay, so this is my RA. RA is in between 360 and 420. So you can see that RA is in between 360 and 420. So to find RA, I will simply have 360 multiplies 420, divide this by the total summation of the entire resistance which you obtained earlier as 1000. So divide by 1000. This is going to be equal to, let's obtain 360 times 420. That gives us 151,200 divides 1000. So this simply implies that RA, okay, we can keep it somewhere here. This implies that RA is equal to, if you divide it by 1000, you have 151.2 ohms. Okay, so that means we have been able to find the first part of the star network RA. So you identify the resistors in which the unknown resistor or the star resistor lies in between. Find the product of these two resistors and divide it by the summation. That's all you're doing. Now we want to find the next, which is RB. So we move back to the diagram now. Okay, you observe now that ROB is lying between 420 and 220. So you identify the resistors in which the unknown lies in between. So I have these two. So ROB is lying between 420 and 220. Find the product of these two resistors and divide by the equivalent summation which we obtained earlier. Okay, so ROB is definitely going to now be, we have 420 multiplies 220 divide by 1000. Okay, divides 1000, and this is equal to, let's find 420 by 220. So we have this to be 92,400, 92,400 all over 1000. So this simply implies that RB is equal to, if you divide it by 1000, you're going to have 92.4 ohms. And finally, to find RC, okay, let's fall back to RC. Let's fall back with the diagram. Now also find the two resistor where RC lies. So this is my RC. RC lies with this resistor and this resistor. So these are the two resistors in which RC lies in between. So you find the product of these two resistors, divide by the equivalent summation which we obtained earlier. That gives us RC. So that means we are multiplying 360 by 220. Okay. So RC equals 360 by 220 all over 1000, and this is equal to, let's obtain 360 by 220. That gives us 79,200 divided by 1000. So this simply implies RC is equal to 79.2 ohms. Alright, so we have found the values of our star network. Let's now plug it into the star network itself. So not forgetting, this is our star. So we call here RA, we call here RB, we call here RC. So this has been transposed into, now let's put in the equivalent values. Okay. Alright. Now we found RA earlier. Let's fall back to our calculation. We found RA earlier as 151.2. So we fall back to the diagram. RA is 151.2 ohms. We found ROB as 92.4, and this is ROB. So, and this is ROB. So we found the value as 92.4 ohms, and we found RC, and we found RC as 79.2. This is RC, so this is 79.2 ohms. All right, so that's it, and that's how you convert a delta network to a star network. Now, just to confirm that we are correct, now we are going to be converting this star network now into a delta network and see if we are going to be achieving the correct value which we achieved. So this video will also explain to you how to convert a star network into a delta network. All right, so let's try to convert this star network and see. So we want to convert the given solution obtained earlier, which is a star, into a delta and see if we are going to obtain the same result as the original question. So forgive me, the diagram is not too accurate, but then let's call here RA, call here RB, call here RC. So we are looking for the equivalent values RA, RB, and RC to convert this into a delta network. So once again, what I will advise you to do, we are following a shortcut here, is to draw the delta network and impute the star into it. So let's do this and see. So this is our delta network. We call the RA, we call the RB, we call the RC. Let's plug in our known star network now. Okay, so from our star network, this value was given as 151.2 ohms. This value over here we had 92.4 ohms. So you have 92.4 ohms, and over here you had 79.2. So this is 79.2 ohms. So these are the values of the star network. Okay, now let's try to convert this. So in converting a star to a delta, this is what you do. So we start with RA. RA is equal to, this is what you do. Find the loop that forms a complete triangle with the unknown term RA. That's what you do. So I want to find RA. The loop from this circuit that forms a complete triangle with RA is simply from here, this point, and this. So I have this loop forming a complete triangle with RA, which is the unknown. So to get my unknown, I will simply find the summation of these two, which forms the complete triangle. So you're adding these two resistors, which form the complete triangle with RA. That is 151.2 plus you have a 92.4. Okay, now these are the resistors which form a complete triangle with RA. Now the next thing to do is plus, you still find now the product of these same two which forms a complete triangle with RA. So I have 151.2 multiplied by 92.4. Now you're dividing this value by the remainder which is not part of the triangle, and that remainder is simply 79.2. So divide 79.2. Let's see if this will give us our original value. So RA is going to be equal to, let's find 151.2 plus 92.4. So we have 243.6. This gives us 243.6 plus. Now let's find this product divided by this. Once again, 151.2 multiplies 92.4 divide by 79.2. That simply gives us 176.4. So we have 176.4. Now let's add these two and see. This simply implies that RA is equal to, adding these two now, plus 243.6. You see the value gives us 420 ohms. So RA is actually 420 ohms. Okay. Next, we want to find RB. Next, we want to find RB. So just like we did previously, you find the loop which forms a complete triangle with RB. This is RB. The loop that forms a complete triangle with RB is simply this, this, and this. So the resistors present there are what? 92.4, 79.2, and ROB. So these are the two resistors which forms a complete triangle with ROB. So once again, you add these two resistors, you have 7, you have 92.4, okay, plus you have 79.2 now, plus, so you find the product of these two resistors again. 92.4 multiplies 79.2, now divide by the particular resistor which is not part of the triangle, and in that case this particular resistor 151.2 is not part of this triangle, so you divide by 151.2. So let's do this and see. This implies RB is equal to, so let's find the summation. 92.4 plus 79.2, that gives us 171.6. We have 171.6 plus, now let's find this product. 92.4 multiplied 79.2 divides 151.2. 92.4 multiplied 79.2 divides 151.2, that gives us 48.4. So we have 48.4. Now let's add this together with 171.6 plus 171.6, and this simply gives us 220 ohms. So we have 220 ohms. So RB is simply 220 ohms. Finally, we want to find RC. You also consider the loop in the circuit which forms a complete triangle with the unknown RC. So this is RC. The loop that forms a complete triangle is this, this, and this. Okay. So you find the sum of these two resistors plus find their multiplication divided by this one which is not part of the triangle. Okay. So let's do it and see. So RC is equal to, so once more, let's take a look at the diagram. So this, and this makes a complete triangle with RC. So we find the sum of these two, 151.2 plus 79.2. Okay. So we're going to have 151.2 plus 79.2. Again, plus, now you find the product of these same two, which is 151.2 multiplies 79.2, but now dividing by the resistor which is not part of the triangle. So these are the triangle with RC, whereas this resistor 92.4 is not among the triangle, so you divide by 92.4. Okay, so divides by 92.4, divides by 92.4. So let's see what this value gives us. This is equal to, let's find 151.2 plus 79.2. That simply gives us 230.4. So we have 230.4 plus, now let's find this product, divides by 92.4. 151.2 multiplies 79.2 divides 92.4. This simply gives us 129.6. So we have 129.6. Okay, now let's add 129.6 plus 230.4. So this simply gives us 360. So this implies that RC is equal to 360 ohms. Okay, now let's plot our circuit. So not forgetting, we call their RA, we call their ROB, and we call their RC of the delta network. Okay, so remember. Okay, all right, so we had RA, so we had RA as 420, and this is our RA 420. We call their ROB, and we had RB as 220, as can be seen here. we had ROB as 220. So this is our ROB 220 ohms, and we had ROC as 360. So this is 360 ohms, and now this is the equivalent delta network which we solved initially from the given question. Let's fall back to the original question. Okay, so as can be seen in the original question, this is 420, this is 220, and this is 360. So which means the approach or the procedure is very correct. All right, guys, so that's it on how to convert a delta network into an equivalent star network, and also how to convert a given star network into an equivalent delta network. I will see you in the next video with another example. Thanks.